Hello, everyone. So my name is Nathalie Winterlich. I am quality manager at MTU. And on behalf of our team, I would like to welcome you here today to our webinar, How HD Interacts with PFMEA. So we are the AESQ HD Problem Solving SMIC team, and we are presenting you today the following topics. First of all, I will start with an overview of our team and its purpose, so you get to know the team members and our work. Then Pete Titi will start with an overview. We'll continue with the interaction between HD and PFMEA and present the idea behind this. And afterwards, he will talk about how the interaction can be realized. After that, Václav Pisa will take us on a journey and guide us through a case study so that you have the chance to follow an interaction in a realistic scenario. After hearing theory and practice, you are free to ask your questions. And finally, I will provide some more information about the next webinars. So let's get started. For you, it is important to know that we are recording this webinar. So the link to the video will be distributed after the webinar. You may also find it on the AESQ website. If any questions arise, please use the chat function, and we will also use some Slido features for interactions. Our team will also always have a look on the chat function. And as already seen on the agenda, we have a special slot for your questions as well. We kindly ask you to remain mute during the presentation, and we will also mute everyone at the start of the webinar. So what is today's webinar about? The PFMEA is a key tool of the AS 13100, and we all use it for risk identification, assessment, and mitigation in order to prevent potential customer escapes. Nevertheless, the customer might receive a non-conforming product for which PFMEAs have been performed. Customer escapes result in another important tool, the HD investigation. And there, the investigation may lead to identification of failure modes, causes, and corrective action controls that were not originally part of the subject product's PFMEA. For this reason, we need to update the PFMEA with the missing information to assure the new knowledge. In other words, the lessons learned are not lost. So in this webinar, we will emphasize two things. First, the importance of updating the PFMEA as part of the standard work in conducting an HD root cause investigation. And second, how one can use the PFMEA as part of conducting the investigation. Now we get to the question, what is the problem-solving SMIC group and what is our mission? So we want to assist in the development of knowledge and the understanding in the AESQ supply base, and also help to apply and use our consistent and standardized problem-solving methods in order to reach zero defects. So we want to increase the communication with the supplier base and also the knowledge how to use the RM 13000 in big, small, medium-sized problems. And for that, we also created templates and examples. Another important topic is to keep the RM with current issues and suggestions. Also, we want to increase the buy-in, and we giving a sharing platform for lessons learned. Who are we in person? So the group leader is Maniham from GE. and her co-lead is Jun Sakai from IHI. We also have in our team Pete Titi from Pratt & Whitney, Peter Papadopoulos, also Pratt & Whitney, then myself. We also have Adam Rogers from Honeywell, Roger Person from GKN, and also Sharon McGowan from Rolls-Royce and Václav Pisa from GE. So you can always contact us about any specific problem-solving topics, and we are also showing you at the end of our webinar the next scheduled webinars. As previously mentioned, the problem-solving SMIC group supports the use of a reference manual RM 13000. It provides the user with guidance to properly implement the 8D root investigation and its quality management system. So yeah, the purpose is to raise the overall problem-solving capability in the aero engine supply chain, as well as to standardize the whole methodology across all suppliers. The RM 13000 supports the AS 13100 and provides also detailed guidance and, of course, case studies for an easier understanding. The reference menu was developed by our dedicated team from all AESQ member companies, and of course we try to implement our expert knowledge and experience we have in root cause analysis and how to conduct escape investigations. You can find the RM 13000 and the templates on our website. And you can also find the community of practice on LinkedIn, and recommend to join us. We currently have 483 members, so feel free to join us. And now I will pass you over to my colleague, Pete.
Thank you, Natalie. That was a wonderful introduction. I'm going to walk everyone now through the 8D PFMEA interaction. Let's begin with a question. Should a PFMEA, using your Slido, should a PFMEA always be updated as part of an 8D root cause investigation? Yes or no? Let's see what we get. I think it's kind of what we've expected. Very high on the yes. There may be occasions where no is the right answer. This is more of a discussionary thing. But as we're going to portray it through the rest of the package, PFMEA being updated should be definitely part of any root cause investigation standard work, especially when it involves a part that's designated as a PPAP part, some type of critical to quality part that has a PFMEA produced. So let's continue. And we got another question. We're going to have a few of these, by the way, so keep your Slido handy. Why would we, and this is an open-ended question, why would we update a PFMEA as part of an 8D root cause investigation? Why would we take that extra action to update the PFMEA? Yeah, capture lessons learned. Wow, that's a great start. Knowledge management. So you may have new quality or manufacturing engineers coming on board. Isn't a PFMEA a great learning tool for a new engineer who's supporting that particular area, that cell? That's an excellent answer. Eliminate recurrence. Wow. So that way we assure that the controls that were defined in the investigation, get put in place. And, for the long term, so when new product gets designed, we may look at the prior PFMEA as a lessons learned to understand what controls were put in place to prevent recurring escapes. Wow, this is great. You guys really captured a lot of powerful stuff. You can see the biggest word cloud here, the capture lessons learned as we go forward, because we're always going to be designing new products, new engines, new components. And, so we don't want to make the same mistakes in the past. And so that's probably one of the biggest, if not the biggest reason to do it. All right, let's move forward. I think we captured even the DFMEA. I saw that. That was awesome. This slide, we have shown this a number of occasions, and it's not the full scope of interactions between the AESQ reference manuals. It shows partial scope. But you can see where RM 13,000 on the very right side, how that feeds into PFMEA and control plans. As Natalie mentioned in the purpose slide, we may define some new failure modes, some new causes, some new controls. And we want to make sure that we don't have a PFMEA that's out of date. It's a living document for a reason. And so we want to update that as part of any investigation standard work. Process control methods interacts with that as well. The control methods talked about within RM 13,006 may be some of the controls used for the causes of the failure modes coming out of the investigation. So that's an interaction point right there. And human factors, RM 13,010, certainly when we talk about the dirty dozen sources of human error and how to overcome them, that comes out of an investigation, and how to overcome comes in the way of strategies and devices and process control methods. So that interacts with 13,006 and then updating the PFMEA and the control plan. So they all intertwine. There's no getting away from that. And there's a lot more of these interactions. And as we define them further in the future, you will see different webinars and themes coming up based on the interactions of these reference manuals. Next. So, given what we just said, what 8D step do you think of all the 9 steps? It's kind of funny to say 9 steps in the 8D process, right? Because they added D0 in the 2000s. Which one would involve updating the PFMEA? Wow, this is good. I think we're all agreeing it's not part of the emergency stop actions that occur right away. Well, some of us think it might be. And temporary, it's not a temporary containment action. There's a lot of consensus there. The dominant bar, of course, is the preventive action, D7. So let's go to the next slide and talk about that a little bit. So we're showing here, D7, and that's where we define systemic preventive actions on product we may not even have designed yet. This is where we update systemic things like standard work that people work to that could have impact more than one part number. A design manual may get updated by engineering to capture, better methods of, let's say, part marking or identifying key product characteristics. That impacts more than one part. PFMEA and quality management system procedures. These are all D7 actions, all D7 types of things that we update. The key word here is recurrence. We want to prevent recurrence. And that came out in the word cloud. We saw that. Next. So here we have the 9 steps in the 8D process, D0 through D8. So now we're going to ask you another question. Where does PFMEA have touch points within the 8 steps of 8D? Looking at it in another way, which 8D steps could the key PFMEA documents, the process flow diagram, which is the PFD, characteristics matrix, PFMEA itself, and control plan, where would they come in or get involved in the 8D steps? Oh yeah, this is starting to look pretty good here. So I don't know, can we see the rest of the D's? Are they on the slide or?
They're in the Slido poll, Pete, but it
Okay.
scrolls the most frequent to the top.
Okay, wonderful. So let's now we can see like identifying where the causes are, where the failure modes are. You know, D4 is truly where we start getting into the root cause analysis. Certainly there's going to be a lot of interaction there because we're going to draw those root causes into the PFMEA in the appropriate column that align with the failure modes that were subject of the investigation to begin with. And so, in terms of defining the problem definition, flow mapping can be a certain key point in that, where we identify the escape and generation points of a particular investigation. So the flow map is going to be also an important part. And that'll be in the D2 step. So let's go to the next slide and let's look at this starts the discussion around this interaction matrix that our team put together. What we're attempting to do, and this is a tool that can help any of our AESQ members or suppliers. Again, remember, we utilize the same tools. So D0, D1, all the way through, we can see the various touch points. Look at the flow diagram and how many D steps it touches. You know, from the very first step, identifying where we have holds, where we may have to put quality alerts or flags. You know, and I won't read all these off. D3, which is our interim containment. This is where, you know, a step that requires additional temporary inspections that'll allow for the flow of material while we're assuring all the non-conforming material to prevent delivery of the non-conformances. So again, and then of course, D4, this is where we examine the generation point for documented sources of variation, which led, you know, to the causes that get identified. And of course, the escape point, as I mentioned earlier, you know, how did the customer find the issue and not the producer? And so we would want to understand that step. Moving over to, like, say, the PFMEA under D2, this is where we look at, well, what are the requirements that were violated from the engineering definition? This is where we assess the failure modes, which is the opposite of the requirements. And, you know, again, this is a very big portion up front in an investigation is understanding what actually was supposed to happen and then what actually did happen. That's the initial gap analysis that gets done. You look at the PFMEA a little bit further down in D4, again, this is where the causes of the failure modes get documented in the appropriate column. That leads to the preventive and detection-based controls. So now if we go down one more slide, we'll continue it all the way through to the remaining D steps. And again, look at the PFMEA, D5, D6, D7, the control plan, very prominent in the corrective action step D5, where we identify permanent corrective actions, what we call PCAs. And, this is where we need to update that control plan with those new controls that were identified out of the investigation. Update the control plan for any new control method that may have been identified. Also identify controls that may not have been effective. Why didn't they work? And do they need to be more robust? Do we need to add additional controls? This is all PFMEA thinking now coming from the investigation. It's incredible, the interaction between these two AESQ tools, 8D and PFMEA. Also in the D5, this is where we look for whether or not the controls selected are mistake-proof or error-proofing devices. I can tell you this, where I work, we're going to have a lot more emphasis on the types of corrective actions that get selected when we have a customer escape. Are they level 1 mistake-proof devices that prevent the cause of failure from ever happening? Is it a level 2 device that's a warning device that tells you entered the error state and gives you a chance to get out of it? Or is it a level 3 type of device where the defect's been made, but we are alerted and we can contain it? That all goes on the control plan. Next slide, please. So now I get to turn it over to my colleague, Vaclav Pisa, who's going to walk us through a case study that illustrates this interaction between 8D and PFMEA. Take it away, Vaclav.
Thank you, Pete. Next slide, please. So this is a case study that we prepared to show you in real how you can handle situation when there is an issue. And I now take you through the problem that was defined as a finding done by engine manufacturer on March 3rd, that the product that is a fuel air bracket cannot be installed at floor because it's not fitting properly, because it seems to be too thick. The supplier producing the fuel air brackets initiated the quick investigation at the same day afternoon and discovered by randomly pulling some pieces out of the Finnish stores that they have a bigger thickness that it's expected or required by drawing, which define the thickness as a 0.750 plus minus 0.010. However, based on the investigation, there were parts being up to 763, which means over 0.0303 over the high limits. A notification of escape was issued by the manufacturer to the customer after it was discovered that the measurement device, which in this case was a dial indicator gauge, that was used for acceptance or rejection by the operator. The finding was that this gauge was defective. It was found to be miscalibrated with a bias up to 0.003 in the upward direction, which means that all parts that were measured in the range from 0.758 up to 0.760 would be non-conforming because actual value was 761 to 763. The impact on the customer was The thickness being over high limit that caused that the fuel air brackets would not be possible to install into the next at the next step. Okay, next slide, please. This is a logic tree, how we see that the problem investigation and root cause analyzing should be done. So at the first step, there was a process audit on operation 110, and operator interview concluded. A review of operator checklist, the process was set up correctly. Proper CNC program was loaded into the machine controller. CNC program was determined to be correct. The tool utilized per work instruction was validated. Tools, fixtures, and gauges were free from the FOD, so for a foreign object agreed, per pre-flight checklist. So this audit proved that there is not a problem in the process. Therefore, the focus was put on the measurement system. The failure mode was defined as a part thickness over high tolerance limit by 0.03. In next three steps, there were a review of the gauge R&R that was considered as acceptable. Then was an inspection of the standard work and operator training. So validated operator was following inspection, the standard work, and was trained properly per posted skills metrics. However, the work instruction was work instruction or standard work did not include a local calibration of gauge using a gauge block, which means that the device that was used to inspect the parts was not calibrated before the inspection. Therefore, the calibration was reviewed for more details. There were gauge calibration status. The review of the process provide the information that the validate gauge being used did not exceed the calibration date, so it was calibrated as was expected. However, the supplier discovered that gauge was miscalibrated by calibration lab. Although not the local operator calibration using gauge block prior to running first piece. So the first case was a dial indicator gauge operator was using a miscalibrated the calibration lab. The case 2, the operator calibration check not employed at the operation 100. Prevention control edit in this case was to add the calibration check. Means the instruction now should include a calibration check with a 0.750 gauge block prior any inspection. And as an unfinished business, the root cause to calibration lab miscalibration should be still run. So you can see it at the bottom. As a next step, it should be, for example, the 5Y tool, understand why this happened, why the device was not calibrated properly. Concerning the colors, so the red are likely contributing processes, yellow are possible contributing processes, and green are unlikely contributing processes. Next slide, please. And this is a next question. So in this moment, what kind of documents should be updated? There is a PFD, process flow diagram, PFMEA, control plan, PFD and PFMEA, or all of above. Okay, we have 18 answers. So far, it looks that all above should be updated. Then on the second is the PFD and PFMEA. It's growing slowly, but looks that it's okay, we can wait 1 more minute. Let's see if this will change or not. Okay, it looks that the 75% would update all above, mean the process flow diagram, the PFMEA and control plan, and 24% would make an update of the PFD and PFMEA only. Okay, Pete, do we have any comments to this one? Because we discussed this internally.
Yeah, the only comment is if there are changes like adding a step, anything that would alter the process plan, absolutely the process flow diagram would have to be part of the answer. If the changes are to improve a step, building better instructions, changing tooling, altering the step, not adding a step, but altering it, then it would not be included as part of the answer. So that's all. But certainly the PFMEA and the control plan, because as Vaclav showed on the prior slide, we identified new failure modes, we identified new causes, we identified some prevention steps to add a calibration locally by the operator. So is adding that calibration another step that alters the PFD? Not necessarily. Does it alter the sources of variation column in the PFD? Absolutely. So then the PFD would be updated if we have to update the key inputs and sources of variation. So this is just part of what your teams have to discuss as you go through an investigation. What documents do need to get updated? There's no instant pudding for any of this, but for sure the PFMEA and control plan. So
Yep, I agree. So this can be handled case by case. There is not only one right answer. You have to always consider the process and kind of the findings that you did. Okay, next slide, please.
If I could just interject, I think
Yep.
2 slides were missing, 15 and 16. I don't, and that's why I'm realizing this is going by a little quick. There was a lot on those slides. 15 was all about the key questions to ask as part of D7 step. I don't recall us covering that. And if we could just go back real quick, I don't know if they're missing in that deck. It would be after the Slido slide. What 8D step would updating a PFMEA fall under? So it's before this slide. Yeah, it looks like they're missing. So rest assured, it will be in the package that gets posted. For whatever reason, it looks like they got dropped out of the package here. I could do a quick share if you want me to do it that way, or they're kind of important slides. I don't know if that would alter the webinar in any way.
Go ahead and share,
Okay.
Pete. Go ahead.
I will do that. And let me bring that over. These are the slides I'm referring to. start with this one here. Yeah, so as part of, this is a key slide in the deck, and you'll have it, trust us on that. What questions would you ask if you have an 8D standard work as part of the D7 step? This slide will help you in that regard. Some questions to make part of the 8D investigation. Were new failure modes identified? If the answer is yes, then we do need to update the PFMEA. Any new causes of failure modes identified? Did we determine the current controls were inadequate? If we did, and meaning we need to come up with new robust controls to address the escape, then of course the PFMEA has to be updated and the control plan. Were the current controls active when the failure mode was generated? Maybe the current controls are adequate, but they, for whatever reason, weren't utilized. That's part of the investigation. So we'd want to understand why that would have happened. Was the control system modified to become more robust? Then clearly we would update the PFMEA and the control plan. And finally, any new process steps or changes to the part process plan, then we would definitely update the process flow diagram as well as the PFMEA and the control plan, because they all have to account, all three documents account for all the steps in the process plan. And that would lead to this slide here. Let's see here. This. So here we have a PFMEA at the very top, and we're trying to look at the touch points of an 8D. So the first three columns, any new process steps or changes to the part process will impact columns 1, 2, and 3. And we would update those three columns. If we have any new failure modes identified, then we update column 5. If we have any new key characteristics selected by the producer as process key characteristics being used as a control method utilizing tools out of RM 13006 like pre-control or SPC, then we're going to need to update columns 8, 10, 11, 19, 20, and 21. And possibly the special characteristics column, which is on the PFD and the control plan. So again, this helps us understand what needs to get updated based on the outcome. If we have any new failure mode causes and any new prevention-based controls that get identified, then we update columns again, 8, 9, 10, 11, 19, 20, and 21. And possibly the key process input column on the flow diagram. So again, this could be very helpful here. If we have any new detection-based controls identified as part of the root cause corrective action plan, any new detection or inspection-based controls, we would update columns 12, 13, 19, 20, and 21, as well as the control plan. And again, I won't read off the headings of every one of these columns. And so you can see updating those columns will lead, from either, whether it's a potential cause of failure or detection control. We also need to update the control plan and the reaction plan column on the control plan. The reaction plan column, remember, instructs the operator, once they've entered an error state, how to get out of it. If the control gives you a signal that something's not right, you've entered an error state, the reaction plan provides the instructions of what to do. How do I get out of trouble and avoid the failure mode altogether? And finally, on the right, we update failure mode risk assessment, columns 22 through 27, with a reevaluation of severity, occurrence, and detection. Now, most of the time, if not all, severity is not impacted by anything we do in the process. That comes from engineering on the impact of that failure mode. So it's primarily going to be occurrence and detection as the risks that you would be updating based on your risk mitigation of the controls you put in place. So keep these slides handy and laminated as part of your, 8D investigation process. Both of these, the key questions and the touch points within the PFMEA. With that, I am going to stop sharing and turn it back to Becky and bring back Natalie for the conclusion of the webinar.
Thank you. Thank you, Pete. So what is the conclusion of today's webinar? Point 1. Any changes to a process flow would result in changes of a PFD. Any new failure modes or new causes coming out of an investigation result in an update of a PFMEA. 3. If any of the new 8D corrective actions might be adding a new type of control that needs to be added to the PFMEA. And lastly, control plan needs to be updated accordingly to the PFMEA. So please keep that in mind. And now we're coming to the part you've all been waiting for, your questions. So the first one that I see is this conversation assumes that people can quickly find it. A PFMEA exists and they get a copy of the most current version and version history. How do you do that when the PFMEAs are scattered in the non-integrated spreadsheets?
Let's see, where's that question? Let's see. And where is that question posted?
518. At 518.
That's in the slide? Oh, that's in the chat function.
In the chat function.
Oh, okay, I see. General, we are not, this is the one in general, we are not used to opening a PFMEA at the start of problem solving. That's the one. It is important to open it. I just want to make sure I'm on the right one here. This is 1149. So this question here, yeah, as part of an investigation, first and foremost, and again, this goes for anybody, you need to have some form of standard work. How do we approach the investigation? How does it get started? Who leads it? Who pulls the right people in? And then who ultimately asks the question, has a PFMEA ever been done on this particular part number? If we're talking about a part-related, product-related issue, and most of the time we are, at least in the context of the webinars that we've been running. So, first and foremost, is there, because PFMEA is getting to become more and more and more required, it's advisable to have some kind of PFMEA database somewhere where you can pull them, when you need. And so that you have to look at that first. And is that part of your manufacturing engineering function to execute those PFMEAs and manage their update. Now, if you have an investigation that has to be done, where I work, we have what are called investigation managers, and they're the ones that pull they do the D1, pulling the team together, and they ensure that the standard work is followed. And so with the team, they go through each step. So one step would be, do we have a PFMEA as part of this particular part number? And if we do, then we know there's got to be a flow diagram, a PFMEA, and a control plan. So you'll know that right off the bat, but you got to know where they're stored or who to call or where to go access that information. So that's all behind the scenes that has to be done as part of the standard work. How to answer that question. There's instructions around that. So because none of this just happens by itself. So now once you get past that and you pull the PFMEA, you find out, oh yeah, this particular part we had customer escape on, we have a PFMEA for it. Well, what was the actual non-conformance? That's the failure mode. Does that match up with anything we've identified already? Let's check the failure mode column. If it does, what were the causes identified for that in the PFMEA and what controls? And so now with the process flow diagram, we can determine the generation point where the failure mode originated and investigate the control system right there. You're already knee deep into the investigation. Then you could also investigate the detection column as to why it got out, how it failed to detect the problem before it got out to the customer. Now, if that failure mode wasn't part of the PFMEA, that's new. And now you know you have to update that and then understand the causes behind it and the controls that will need to be there to prevent it. So either way, pulling the PFMEA is one of the first things we would want to do.
Okay.
Okay.
Thank you, Pete. The second question. It's a bit later. In general, we are not used to open the PFMEA at the start of a problem solving. It is important to open it also at the start because we may have already some of the work done. If the failure mode is in it, check causes and investigate them. Do we have our prevention control robust enough? If you do not have the failure mode, update in D7.
Yeah, it looks like, oh, that was from Jocelyn. Yeah, Jocelyn wasn't actually providing a question. I think he was providing an answer, which I agree with.
Exactly.
He's saying why you
kind
would
of
pull it
comment.
out. Yeah, go ahead, Jocelyn. Go ahead. Jocelyn's part of
Yeah.
our AESQ team, by the way.
Hi everyone. Just quick comment. We found that in our company in general, we are not always used to open the PFMEA at the start of the problem solving. We were quite used to open it maybe around D7, D6 in order to see something, but we are not used to open it at the beginning. And this is a shame because if the PFMEA is well done, we may have plenty of already information. So that means we have already think about what kind of problem could occur, and we may have already think about possible causes. So this is already something that we can put and analyze and investigate, and do not start from scratch, I would say. So it's always important to open the PFMEA at the end and check, do we have something? Yep. If we have something, we do something. If not, we will update at the end. Just a comment.
Thank you, Jocelyn. Excellent.
Thanks.
Okay.
Nice session, eh? Also, I enjoy a lot. Good work.
Thank you. So when to use 5Y and not 8D?
When to use 5Y and not 8D. Well, 5Y is a root cause analysis tool that's part of the D4 step. So I don't quite understand the question, but maybe I do. I mean, there could be a problem that could occur that doesn't require a full-blown 8D investigation. It might be something that's contained within a plant site, within a factory area, one machine, let's say. Maybe we had an issue where something, a nonconformance was discovered as it was being produced by the operator or the inspector, and it's contained to that machine. Well, that didn't get out. The customer never received it. There's no need to do population bounding. But we may want to certainly understand the root cause of the nonconformance found at that point in time. That's where a 5Y could become very useful, but not a full-blown 8D. That leads to one of our webinars coming up, 2D, 4D, 8D. And the inspiration of that came from MTU because they recognized long ago, not every problem requires all the 8D steps. You know, if you go to turn on your lamp in your living room and it doesn't go on, what's the first thing you're going to do? You're not going to tear apart the lamp and look for a wiring problem. You're going to see if it's plugged in. And if it's plugged in, then you're going to check the bulb and replace it. And chances are you'll solve the problem. You don't need a full 8D investigation and documentation around that, right? So that's going to be a very interesting webinar. But yeah, there are times, I guess, where, yeah, you could utilize like 5Y when you're problem solving out of, it doesn't necessarily have to always be part of an 8D investigation. That's a great question. I'm glad you asked that.
Pete, it's Marnie, sorry.
Yeah.
One more thing, sometimes if they're talking about working with GE, they have a 3x5 form, 3x5Y form, which is really an 8D, but the language isn't used as 8D. So I think sometimes people get confused and think it's only a 5Y, but we actually cover all 8D steps within the form. They're just not labeled.
Right,
so just in case that's what the question was, like the GE 3x5Y form, which is a 2-page PowerPoint, is actually one of the templates that's uploaded, but with all 8D steps labeled.
Yeah.
So sorry, I won't interrupt.
No. And by the way, folks, Marnie Ham is our subject matter interest group team leader. So no, that's a great point. And all the touch points of 8D are on that form. There are 3 beautiful report templates on the supplemental materials website. Please check that out. There's so many useful tools there. And we're going to be adding more as the months go by. We're always looking to add more things that could help people out. So I know in our process control team, we're always looking to add some new tools and templates that can make things easier. So again, we want to try to help the supplier implement these requirements of AS 13100. PFMEA 8D are 2 key elements. There's no way around that. Are there any other questions?
Yeah. After an issue with an ID that induced the PFMEA to be updated, shall it be presented again to the customer as part of a PPAP resubmission?
Yeah, if the customer requires any time a PPAP, I'm sorry, like most PPAP submission forms have an area when changes occurred And depending on the submission level, it might require the supplier to present that as part of an update, kind of like a Delta FAI or a partial FAI. And so, but that doesn't necessarily mean you have to do that in every case. So submission levels could be 1, which says you submit the warrant and it says, yeah, we've changed this. We updated the PFMEA based on this investigation. If you want to see it, we'll provide it. Otherwise, we won't bother providing it. That's acceptable if it's a submission level 1. And level 3 requires submission of all objective evidence on every element. And it would require submission on any element that was changed. PFMEA is certainly an element. So if there was an 8D investigation and it required the PFMEA documents to be changed, that would require the submission form identifying those elements of PPAP, PFD, control plan, PFMEA, and the objective evidence if it's a level 3 submission. So you really got to go through that. That's all mapped out in Chapter B, AS 13100, and RM 13145. That's the APQP PPAP reference manual. So that's all mapped out in there.
Okay, thank you. Next one, if during the analysis we detect indirect and direct causes, it's necessary to translate indirect causes to our PFMEA.
Yeah, so if you come up with direct causes, as you will detection causes, and in many cases you're going to find system causes, but the direct causes generally associate with the prevention control column in a PFMEA. What can you do to prevent the cause of failure? Detection or escape points that are identified why we failed to detect the failure mode, how it got out to the customer, that you may come up with some additional inspection or test to help protect the customer. And that would certainly have to be updated on the PFMEA if that were going to be done as an ongoing part of the control system. Notice what I said, as an ongoing part. Sometimes you come up with a D3 action, which is a temporary over inspection to help protect the customer while you work on the direct cause and to prevent it. Temporary actions don't have to be updated on a PFMEA. It doesn't hurt to make it a note on there, but those would not be required. PFMEA should reflect the controls that you're going to utilize day in and day out that ultimately get populated on the control plan and into the work instructions.
Are there any more questions? Okay, so thank you for your questions. So yeah, as already said at the beginning, our resources will be available on our AESQ website, and we will send an email to all registrants with a link. So thank you for attending today's webinar. It was a pleasure for us, and see you next time.
Thank you, Natalie.